welcome back to our channel. In this video we will discuss about purpose of gravity disk in Purifier, and one more thing is it's a lengthy video around 20 to 25 minutes. I will give you assurance if you will spend 20 minutes on this video, you will never forget about this topic in your lifetime. So please don't skip with any seconds. Let's move on to the video. So we will see purpose of gravity disk by using settling tank analogy. So for that I will take one settling tank with A and B sides. Here you can see A side is higher than B side, and I will pass the fresh water from A side, and fresh water is overflow from B, and I will stop the supply if the overflow happen in B side. After that I will attach to the partition plate CD in the tank. After I attach a partition plate in the tank, I will pass the dirty oil into that. So dirty oil consists of pure oil plus solid and water. After passing dirty oil to the tank, there is a overflow happens in B side because of same amount of volume will be displaced through this so same volume of water will be displaced when passing dirty oil. After some time, according to Stokes law of purification, Fs means separation force is equal to pi gt cube divided by 6 rho 2 minus rho 1. So d cube is a diameter of the particles. So here rho 1 is a reference liquid. Here we can say oil. Okay, and oil and solid density will be higher. So separation force will act on a solid particle also higher. So after that some time the solid will be settles bottom. After solid settles out and the water and oil density also higher. So after that, after solids will be settles out and water also settles bottom. So after solids and water is settles out, the same amount of volume of water will be displaced through B according to Archimedes principle. Here I take oil density is equal to 0.75 tons per meter cube and water density is equal to 1 ton per meter cube. So here you can see after solid settles out, there is a pure oil in the region and water is there. So here you can see oil and water surface are meet. So this point is called as E line or interface line. So this point is, let's say this point is called as E, and oil head is called as H naught, and water head, this is a water head, those water head represent as a HW. So here E line formation is very important. If E line will be formed near to D, the oil will goes to the water side. If E line is formed here, the water will go to the oil side. So let's learn about how this E line will formed and also how the E line will gives better separation. So for that we see three cases. For that I taken a one manometer, one U-tube manometer. The both sides are exposed to atmosphere. So here one side is filled up with water with the water head of 0.53 meter, and one side is filled up with oil with the oil head of 0.7 meter. So here you can see the E line is formed. So let's say how this E line is formed. So we can know that pressure is equal to density into acceleration due to gravity into height of the liquid. So for E line formation in that point E, so oil pressure and water pressure both are equal. So when the oil pressure and water pressure are equal, at that point our E line is formed. So we know that oil pressure is equal to rho 1 GH1, water pressure is equal to rho 2 GH2. So rho 1, so oil density we see so 0.75 ton per meter cube, and G will be cancels out, and H1 equal to 0.7 meter is equal to 1 ton. So water density, fresh water density we know that, so 1 ton per meter cube into water head equal to 0.53 meter. So here you can see both pressures are equal, so E line will be formed in that point. So in case 1 I will use density of oil with 0.75 tons per meter cube density. So in case 2, I use higher density oil with 0.95 tons per meter cube of density. So same in case 1. So rho 1 GH1 is equal to rho 2 GH2. So G are cancel out. So rho 1 here is 0.95 tons per meter cube into 0.7 meter. It's a water head, oil head, equal to rho 2 is a 1 ton per meter cube into water head is 0.53 meter. So let's calculate. So 0.67 ton per meter square is equal to 0.53 ton per meter square. So here you can see oil pressure is higher than the water pressure. So what will happen in the manometer and the formation of E line? So due to oil pressure is higher than the water pressure, the oil is mixed up with water and flows to the water side. So due to oil pressure is higher, the oil head is reduced and the water head is increased. So E line will formed in the point of F. So if E line is not in E, if E line is formed in F, there is a possible to the oil will pass to the water side and mix up each other. So to prevent oil and water mix each other, we can re-establish the formation of E line in point E. So to re-establish the formation of E line in point E, we can increase the water head to 0.67 meter. For example, we can, in case 1, we use water head with 0.53 meter. In case 2, we can increase 0.53 to 0.67 meter. So what will happen to the oil pressure and water pressure? So oil pressure doesn't change. So 0.67 ton per meter squared. So pressure, so tons per meter squared. And here I can increase the water head. So to filling in that point. So 0.67 meter. So multiple that. So 0.67 tons per meter square. So here you can see both pressures are equal. So oil pressure and water pressures are equal. And E line will be formed in that point E. So let's come to case 3. In case 3, I use less density oil with 0.53 ton per meter cube of density. So same, so rho 1 GH1 is equal to rho 2 GH2. So G cancels out. So rho 1 here on the 0.53 ton per meter cube. H1 is equal to 0.7 meter. So rho 2 is 1 ton per meter cube into H2 is 0.53 meter. So same in case 1. So water head is same in case 1. So multiple that. So 0.37 ton per meter squared is equal to 0.53 ton per meter squared. So here you can see water pressure is higher than the oil pressure. So what will happen to the manometer? So due to water pressure is higher than the oil pressure, water will mix up with the oil and pass to the oil side. So due to water pressure is higher, the water head is reduced and the oil head is increased, and the formation of E line in that point, let's say G. So G. So it is possible to the water side, water will be passed to the oil side. So to prevent that, we can re-establish the E line formation in point E. So for that, so to re-establish the E line formation in point E, I can reduce the water head from 0.53 meter to 0.37 meter. So what will happen? So same. So oil pressure doesn't change. So 0.37 ton per meter squared, and in we can reduce the 0.53 to 0.37. So water pressure is 0.37 tons per meter squared. So oil pressure and water pressure is both are equal. So E line formation is formed in point E. So finally, we can conclude from both 3 cases. If density of oil is increased, E line moves outward and oil mix up with water. And second conclusion is, if density of oil decrease, E line moves inward and water is mixed up with oil. And third conclusion is, irrespective of any kind of density oil, if higher density or lower density, if any kind of density of oil is used in the purifier, we can only changing the water head By increasing or decreasing the water head, we can form the E line point in E. So if I use density of higher density oil, if I use higher density oil to maintain the E line in point E, I can increase the water head. I can increase the water head to maintain E line in point E. And if I use less density density of oil, so to maintain E line in point E, we can reduce the water head. So let's come to the settling tank analogy. So this settling tank is same as the manometer. So YouTube manometer. So here I can use higher density oil with the density of 0.95 tons per meter cube. So due to that, our E line will be formed in near to D. So near to E line is moved outward and formed in near to D. So to prevent oil is mixed up with water, I can add a disc in the point B. I can add, so black color is a disc. So I can add a disc in point B to increase the water head. So by increasing water head by using this disc, I can maintain the E line in point E. So there is no oil is wastage to the water side. If I use less density oil with a 0.53 tons per meter cube, I can. So what will happen if I use less density of oil with 0.53 ton per meter cube? The E line will be formed near to C, and the so water is passed to the water side, and water is discharged to oil side. So to prevent that, I can reduce the water head. So how do I reduce the water head? By removing the disc. Here you can see I increasing the water head by adding the disc, and if I remove the disc from point B, I can reduce the water head. So I can reduce the water head. By reducing the water head, I can re-establish the E line in the point E. You can see from the center line to point E, it means E line. From the center line to E line, the distance will be represented as small letter E, and from the center line, oil surface distance is represented as L, and from the center line, water surface is represented as a H. So you know that oil head is H naught. If you want H naught, if you want H naught, will be rewrite E minus L. So E minus L, we have H naught. And if you want to HW, if E will be minused by H, we will get HW. So H naught is represents E, rewrite as E minus L. HW is rewrite as E minus H. So here what will happen if I use a higher density oil, to maintain the E line in point E, I want to increase the water head. How can I increase the water head? By decreasing the H value. What will happen here? Here I can use less density oil. If I use less density oil, the E line will move inward. So I want to maintain the E line in point E. For that, I will decrease the water head. How can I decrease the water head? By increasing the H value. So finally conclude that if I increase the density, I want to increase the water head to maintain the E line in point E. You want to increase the water head. How can I increase the water head? By reducing the H value. If I use less density oil, we want to reduce the water head. So how can I reduce the water head? By increasing the H value. So by either increasing or decreasing the density value, we will only changing the H value. So by using this disc, we only changing H value, we can maintain the E line in point E. So how can I increasing or decreasing H value? By using this, adding and removing the disc. So let's find out how can find the H value. So here you can see this settling tank is rotated by 90 degree, is formed by. So our settling line is rotated by 90 degree. So how can it be formed like this? So it's one side, it's another side. So like two settling tank attached to each other. So here you can see from the center line to E line, it will be represented as E, and from the center line, water surface is represented as H, and from the center line, oil surface is represented as L. So here you can see it is a H. So by either increasing or decreasing the density of oil, we can only changing by H value, we can maintain the E line in point E. So how can it's let's find out how to find the H value. So we know that rho naught H naught is equal to rho W H W. So H naught is equal to E minus, we know that E minus L, HW is equal to E minus H, we know that. So substitute the values E minus L and E minus H, so the equation comes like this. So here you can see there is a two settling tanks. This is a one, another one. So there is a this is also H, this is also H. So there is a two. So we will add the squared in this equation. So rho naught E squared minus L squared is equal to rho W E squared minus H squared. So rho W will come to the left side equation. So rho naught divided by rho W into E squared minus L squared is equal to E squared minus H squared. So we need H value. We need H value. That only we can either by increasing or decreasing the density of oil, we can maintain the E line in point E. So we need H value. So H will be come to the left side of the equation. These equations are go to the right. So what will happen to the equation? So H squared is equal to E squared minus rho naught divided by rho W E squared plus rho naught divided by rho W into L squared. So here E squared is common. So E squared, so take it out the E squared. E squared is equal to E squared into 1 minus rho W divided by rho naught divided by rho W plus rho naught divided by rho W L squared. So it's a squared. So squared will be come to the right. So it will be comes to root. So root E squared 1 minus rho W divided by rho W plus rho naught divided by rho W L squared. So here you can see H value is the radius. Only H value is a radius. We want to diameter. So it is from the center line to is a radius. We want to total diameter. So we know that T is equal to 2R. Okay. So R is equal to here represents H. So we need a diameter. So diameter is equal to 2R. It is a R. So R is multiplied by 2. So the final equation comes H is equal to 2 root E squared into 1 minus rho naught divided by rho W plus rho naught divided by rho W L squared. So by this simple equation, we can find the H value with respective of density. Here we know if I know E and L value and the rho naught values, the three values, we can find the H value, and so we can increasing or decreasing the H value by irrespective of any increasing or decreasing of density oil, we can maintain the E line in point E. So let us come to the real life purifier. So here you can see center pipe is there. So center pipe is passed, it's a passage for dirty oil, and here the water will be discharged into that pipe, and here is a pure oil. So pure oil passage. It's a pure oil passage. It's a water passage. So let us zoom into this space. Let us zoom in this space. So here you can see this is the path for pure oil. This is the path for pure oil. Pure oil. It's a gravity disc. There is a disc. Is that this is called by gravity disc or tampering. Gravity disc or tampering. So let's say I can use 0.75 tons per meter cube of density of oil. So I can use a tampering to maintain the E line in point E. So if I use 0.95 tons per meter cube, if I change the density of oil to 0.95 tons per meter cube, what will happen to the E line? It will be moves outward. It's moved outward. So pure oil is passes to the water side. So oil is wasted. So to maintain the E line in point E, we want to change the gravity disc. How can I change the gravity disc? The gravity disc looks like it is a circular disc. it's have an inner diameter and outer diameter. If I increase the density of oil, I want to reduce the water head. How can I reduce the water head? By decreasing the H value. How can I decreasing the H value? By decreasing the diameter. So if I use a higher density oil, I can reduce the diameter of the gravity disk. By reducing the diameter of the gravity disk, I can maintain the E line in point E. So if I use 0.67 tons per meter cube, so I will reduce the density to 0.65 tons per meter cube. What will happen to the purifier? For density is reduced, we want to reduce the water head. How can I reduce the water head? By increasing the H value. So how can I increase the H value? By increasing the diameter. So by increasing the diameter. So if I use higher density oil, I want to increasing the diameter of the gravity disk. So by increasing the diameter of the gravity disk, I can maintain the E line in point E. So finally we can conclude that if I use higher density oil, we can reduce the diameter of the gravity disk to maintain the E line in point E. I can if I can use less density oil, we can increasing diameter of the gravity disk by to maintain the E line in point E. So finally, you can learn about what's the purpose of gravity disk with respect to of changing the density of oil. So thank you for watching. So let's meet up in the next video.